Okay, talk about Euler's method today. So Euler's method is really just a method to approximate values of a function. So usually you'll be given an equation, a differential equation, and then you'll kind of have to approximate some of your initial values. So, well, how do we do that? Well, first off, how do we approximate our old value? So let's say that we are asked you to approximate using linear approximation a value. You would just actually try to find the slope, and you would plug it into this. Y equals, not y equals, y minus y1 equals the slope of that, x minus x1. Okay, so that's what we would have done. We would have found the slope, and we would have plugged in and we would have approximated. So what if I move that y1 over? And the reason I'm going to do this is because it's going to kind of look like Euler's method here. All right, so I'm going to kind of relay this to here. So step one for estimating using Euler's method is you're going to choose a non-zero change in x to serve as an increment. So it's your step size. You got to pick your step size. Sometimes the problems I tell you, sometimes you have to figure it out a little bit. That's not the hard part though. So you would just figure out your increments, and then so you would let x1 be this change, which is actually right in here, and then you would let x2 be the next change, x3 be the next change, because essentially we're going to be building these little segments like this over here. You can see in that picture. So we're trying to build these little segments, and then you would compute these. So you would find, which by the way, this looks an awful lot like that, right? You would do y1 is going to be the initial plus whatever the function is times the change in x, and that would give you y1. And then you would use that y1 value for the next one to find y2, which builds the next segment. And you keep doing that until you get to where you need to be in terms of what the question's asking. So sometimes they'll ask you to use two steps to approximate this, and then you would just use 2 steps. You'd just be done after 2 steps. And then just a little bit of accuracy stuff here. This is like back in middle school, you learned absolute error. Absolute error is just going to be the exact value minus the approximation, and that difference is your error. It's always positive. That's why it's absolute value. Percent error, you just divide by the exact value and then multiply it by 100 to get your actual percentage. So just friendly reminders right there. Okay, so let's go ahead and do some Euler's method problems. So given the differential equation, so this already tells us our slope, which is nice. I don't have to find anything. Let y equals f of x be the particular solution to the differential equation with the initial condition of f of 4 is equal to -1. Use Euler's method starting at 4 with 2 steps, so it tells us the steps to approximate 4.2. So we actually have to find out our couple things here. We need to find out what our initial x is, what our initial y is, and what our change in x is going to be. Okay, so it's all going to come here from our initial condition. So we were given f of 4. I'm going to just put everything that's important right in front of us. F of 4 is equal to -1, and it tells us that my slope, my dy dx, is x plus y. So my initial is going to be 4 for x. My initial y is going to be -1. And if I'm doing 2 steps to get to 4.2, well, each step has to be worth 0.1. So I'm just going to do this 2 times. So for x1, if you're stepping, you're going to get 4 plus this 0.1, which is 4.1. And then for x2, you're going to do the previous, which is 4.1, plus your change, which is 0.1, which is 4.2. So you found your initial x, x1, x2. You don't need to write all this stuff down. I'm just writing it for the sake of your notes, just to kind of help you out here. Okay, so to find f of 4.1. So I'm going to come back to this right here. So step 1, I found my x1, I found my x2 just by taking my initial and adding my increment, and then do the same thing to the previous one. Now to find my y1, I'm going to take my initial y. Just leave that right here so we can have it all right here. Oh, it doesn't all fit. Well, take my initial y, which is -1. Okay, plus my function here, which is my dy dx. So my dy dx is right here. And I'm using the initials here. So x plus y would be 4 plus negative 1. Okay. Times the change in x. Change in x is 0.1. Okay. So I'm going to just do a couple of cues here. So this is going to be, this is the first step. That's y1. We're trying to find the first step. This is the initial. Okay. This is my slope, which is dy over dx. And this is my change in x. It kind of looks like it's times 1. It really should be times 0.1. So I'll put it like this. Okay, so that's where that all is coming from for my formula. So to go ahead and solve for this, we're going to get negative 1 plus, it looks like this is going to be a 3 times 0.1 is 0.3, which is going to give me a negative 0.7. Okay, so this, again, reminding you, is y1. So now to find the next one, which is what I'm trying to approximate here, which is going to be y2. I'm just doing 2 steps in this problem because that's all I asked was for 2 steps. I'm going to do the previous. So the previous value was negative 0.7 plus my dy dx. Now I have to use my previous values here. So y1, so it's going to be 4.1. Okay, using this 4.1 plus my x2, sorry, plus my previous one, which is x1, which is 0.7 right here, negative 0.7. Okay, kind of talked to, I'll explain that poorly. So in here, this is my x1 plus my y1 because it's a differential equation right here. Okay, so that's where this is. This is my dy dx. I'm using my x1, y1s now, and I found my x1 here, found my y1 here, times my change in x. And this is going to be my final answer. So again, kind of pointing out the important things here is that this is y1. This right here was my dy dx using x1 and y1. And this is my change in x, doesn't change. Same thing all the way through. Okay, so you're going to do this math, and you're going to get negative 0.7. It's supposed to be right here. 3.4 times 0.1 is going to be 3.4 is going to be point. I don't know what the answer is supposed to be. I can't do this math in my head. What am I, a math teacher? Let's just do it this way. 3.4 times 0.1. And then this is going to give you negative. Yeah, because this is going to give you a negative, got it, negative 0.7 plus 0.34, which is going to give you a negative 0.36. Got it. A little bit of arithmetic there. And there you go. There's your 2-step problem. So as you see here, you just need to get comfortable with it and just get used to doing this stuff. So we're going to do the same type of problem. This time we'll talk a little bit about error. So it says use Euler's method with step size. So this one tells us a step size. Great. To estimate the value of 0.4, where y is the solution to the initial problem. Gives us our dy dx here. If the exact solution is y equals e to the x, we're going to find the error. So we're able to use a calculator here. So here's my given information. So f of 0 equals 1. My dy dx is y. My initial x is 0. My change in x, it gave me that, is 0.2. and my initial y is 1. Okay, so if I'm starting from 0, how many steps am I doing? Doing 2 steps. So I need to find what x1 is. So if I'm starting at 0 and I go up, I'm going to get 0.2. And then x sub 2, if I just add another 0.2 again to that, is going to be 0.4. Awesome. So let's go ahead and find y of, so then I'll just use function notation. Yeah, I'll just stick with y. Y of 0.2, because that's my next step, is equal to my initial y, which is 1, plus my slope, which is right here. So I'm going to use, well, y, the only y value I have is 1, times the step increment, which is 0.2. And that's going to give me 1.2. So to find y of 4, use that 1.2, plus the slope, plug in the 1.2, which is just 1.2, times the increment, which is 0.2. So this one was a little bit more straightforward, because I have to deal with x's and y's in my slope here. This is going to give me, oh boy. Well, I would have a calculator in my hand. So I have it. I'm going to pretend to use it, and the answer here is going to be 1.44. Okay, so there's my answer right there. So I found this. That wasn't what my question was asking, though. So I found that. So y of 0.4 is equal to 1.44. But it wants me to find the actual value here. So if y is really e to the x, well, y of 0.4 is actually equal to e to the 0.4. So I'm going to type that in my handy dandy calculator. So e to the 0.4 equals 1.49182, and I can keep going on and on and on. Okay, so it's just asking for my error. So my error is just going to be one value minus the other. So 1.49182 minus 1.44. And that's going to give me, when I subtract that, 0.05182. So it didn't ask for percent or anything like that, just looking for the error. So it's only off by 0.05 and then some. So that's not too bad. So that's pretty close approximation. If you were to lower these steps, the amounts to like 0.1, it'd be even closer. 0.05, even closer. So that is how you use the approximation method. And that is it for our video for Euler's method. When you're doing this, just go slow, state your givens, kind of work through it until you start to get comfortable with it. That's all it is.